Hello and welcome to the solution video to my AQA 2024 practice paper 2. Before watching this video, I'd encourage you to read the disclaimer that's on the front of the paper. I've put a lot of effort into analysing the past papers and of course what topics already came up in paper 1, but this offers no guarantees at all. There are many topics that I couldn't fit into this paper that may well appear, so I'd remind you to revise all topics as technically anything could still be asked. It is definitely best to try the paper before watching this video. You can find a link to the paper in this video's description. Now let's take a look at the solutions. So in question 1 we've been asked to factorise, which means to put into brackets. This one's going to be a single bracket factorisation. Looking at the two terms here, the only common factor is y, so y will go outside the bracket. Then I need to consider what I would multiply y by to get 5xy and 3yz. To get to 5xy, I need to multiply by 5x, and to get to 3yz, I need to multiply by 3z. So this is the answer, y bracket 5x plus 3z. In question 2, we've been told that a coin is thrown 50 times. 7 of those throws land on heads, and we need to write down the relative frequency of heads. To write down the relative frequency, we just need the number of times it lands on heads as a fraction of the total number of times that we threw the coin. So it's simply 7 over 50. In question 3, we have a shape that has a volume of 5 meters cubed, and we need to write this in centimeters cubed. You need to know that 1 meter cubed is the same as 1 million centimeters cubed. So if we have 5 meters cubed, we need to multiply 5 by 1 million. 5 times 1 million is 5 million. In question 4, we need to find the lowest common multiple of x to the 3 and x to the 5. Now x to the 3 is actually a factor of x to the 5, because you could multiply x to the 3 by x to the 2 and get x to the 5. This means that x to the 5 is a multiple of x to the 3. So the answer to this question is actually just x to the power 5. If you ever have algebraic terms like this in the same letter, the lowest common multiple will always just be the highest power, so x to the power 5. In question 5, we need to find the nth term of this sequence. First of all, we're going to find the difference between each of the terms, and in this sequence it's plus 5. This means the sequence is a 5n sequence. So we can write the 5 times table above the sequence, 5, 10, 15, 20, and so on. And then we need to consider how we would get from the 5 times table, which is 5n, to our sequence. In all of these cases, you need to subtract 13. 5 subtract 13 is negative 8. 10 subtract 13 is negative 3. 15 subtract 13 is 2. And 20 subtract 13 is 7. So it's 5n subtract 13. In the second part of the question, we need to write down the first term of the sequence that's a 6-digit number. So if we take the sequence and we continue adding 5, the next term would be 12, then 17, 22, 27, and so on. Since we're adding 5 each time here, the final digit alternates between a 2 and a 7. So the first 6-digit number in the sequence will be a number that's got 6 digits that ends in a 2. The smallest example of this is 100,002. In this question, we've got Fiona, whose house is worth £250,000 in the year 2024. Fiona is going to assume that house prices will increase by 2% each year for the next 3 years, and using her assumption, we're going to work out how much Fiona's house would be in 3 years' time in 2027. To do this, we'll start with the current value of the house, £250,000, and we need to multiply this by the multiplier for a 2% increase. To work this out, you could take 100%, then add 2%, which is 102%, and then divide 102 by 100, which gives you 1.02. So 1.02 is the multiplier for a 2% increase. So for each year we're going to increase by 2%, so we're going to multiply by 1.02. But we're going to do this for 3 years, so we'll write this to the power 3. All you need to do now is just type this into your calculator, and you get this as the answer, £265,302. In this question, we've got triangle A, which is going to be rotated 90 degrees clockwise about the point -1, -1. To do a question like this, I would advise you use tracing paper. So you take your tracing paper and place it over the grid like this, and then trace over the shape. The centre of rotation here is -1, -1, so I'm going to mark a cross there. I would then place my pen or pencil on the cross and turn the tracing paper 1/4 of the turn in a clockwise direction, like this. So this is where shape B will end up. Now we've also been told that triangle A is reflected in the line x equals -1 to get triangle C. So let's draw on the line x equals -1. That's a vertical line that goes through the x-axis at -1. Then we just need to reflect shape A in this line. I like to do this by marking on the corners of the shape and then counting how many squares it is from these points to the mirror line. So I'm going to do the 2 points on the right hand side first, and it's 2 squares to the mirror line, so I must go 2 squares past the mirror line. Then for this other point, it's 4 squares to the mirror line, so I go 4 squares past it. And the new shape, shape C, will end up here. The question says to describe the single transformation that maps triangle B to triangle C. Triangle B has been mapped to triangle C by a reflection in this line here, which has the equation y equals x. So to get the marks for this question, we need to say it's a reflection in the line y equals x. In this question, we need to estimate the mean speed of the cars. To begin, we're going to write down all of the midpoints for those groups. So the first group goes from 30 to 40, the midpoint is 35. The next group from 40 to 50, the midpoint is 45. And the next group is 55 and 65. We then multiply all of the midpoints by the frequencies. So 1 times 35, 35. 14 times 45, 630. 37 times 55 is 2035, and 48 times 65, 3120. Then we add up the frequency column, which will give us 100, which represents the total amount of cars. We also add up this final column here, which gives you 5,820. This represents an estimate for the total speed of all of the cars. To find the mean, we do the total speed of all of the cars, 5,820, divided by how many cars there were, 100. And this gives you the answer 58.2, which is the answer to the question. In this question, we need to do a calculation in standard form. We're going to divide 1.9 times 10 to the power 600 by 7.6 times 10 to the power 25. We're going to start by doing 1.9 divided by 7.6, which gives you 0.25. Then we're going to do 10 to the power 600 divided by 10 to the power 25. Now you won't be able to do this one on your calculator, but when you divide like this, you subtract the indices. So 600 subtract 25, which will be 575. So it's times 10 to the power 575. This question does say to give your answer in standard form, and at the moment this number is not in standard form. We need that first number to be between 1 and 10. 0.25 is too low. So if we multiply 0.25 by 10, it will end up at 2.5, which is okay, because that's now between 1 and 10. But if we've multiplied that by 10, we should divide this by 10 to keep it the same number. If you divide this by 10, you'll reduce its power by 1, so it will now be 10 to the power 574. And that's the answer to the question. In this question, we have m and n, which are the smallest square and cube numbers that are greater than 5,000. So our first job is to try and work out what these numbers are. Let's start with square numbers. So you may want to use your calculator to try out some numbers here, and if you do 70 squared, you'll see it's 4,900, so that's very close to 5,000. If you do 71 squared, you'll get this, which is now over 5,000. So 5,041 must be the smallest square number that's greater than 5,000. Then if we do the same with cube numbers, 17 cubed is 4,913, but 18 cubed is greater than 5,000 is 5,832. So we've now found that m must be 5,041 and n must be 5,832. We need to show that the difference between those is the product of two prime numbers. So let's subtract them, and if you subtract these, you end up with 791. So we need to show that this is the product of two prime numbers, but it might be quite difficult to guess which two prime numbers multiply to give this. Fortunately, there's an easy way to do this with your calculator. If you have an older style calculator like this, you'll first of all type in the number, so 791, and then press equals. Then we go and press shift, and then this button here where it says fact, and if you do press this button, you'll see that it's equal to 7 times 113. If you have a newer style calculator, you start by typing in the number as well, then we press execute, then we press the format button, and then move down until it says prime factor, and then press execute again. And we get the same answer, 7 times 113. So 791 is the same as 7 times 113. And 7 and 113 are both prime numbers, so we've now shown what we were asked to do in the question. In this question, we need to use trigonometry to work out the size of angle x. We'll start by labelling the sides of the triangle. The longest side opposite the right angle is the hypotenuse. The one opposite the angle in the question is the opposite, and the other side is the adjacent. In this question, we have the hypotenuse, we have the opposite, but we don't have the adjacent, so we won't need that one. Then we write out SOHCAHTOA, and we're looking for the one that has the opposite and the hypotenuse, which is sine. So we can write down that sine of the angle, which is sine of x, is equal to the opposite, which is 15, over the hypotenuse, which is 18. Then to find the value of x, we use inverse sine. So x will equal inverse sine of 15 over 18. If you type this into your calculator, you'll get x is equal to this number here. We might want to round this off to something sensible, so 56.4 or maybe 56.44 for example. In this question, we need to find a formula for m in terms of n, where m is the amount of money in the bank and n is the number of weeks. To find the equation of a line, you need two things. You need its gradient and its y-intercept, although in this case it will actually be an m-intercept, because the y-axis is actually the m-axis and the x-axis is now the n-axis. So we're looking for the y-intercept, which we might call the m-intercept in this case, which is where it crosses the m-axis here, and that has a value of 700. Then we need the gradient of the line. To do this, we draw a gradient triangle, which goes like this. We do the change in x, or rather the change in n, which is 9, and also the change in y, which is now the change in m, which goes from 700 all the way up to 2,500, so a change of 1,800. Then to find the gradient, we do the change in y over the change in x, and in this one it's the change in m over the change in n, but the same idea. So 1,800 divided by 9, which gives you 200. So the gradient is 200. We then look at the general equation of a straight line, which is y equals mx plus c. Of course, we're not working with y and x here, we're working with capital M and lowercase n. So it's actually m equals mn plus c. This m here is the gradient, so we can replace that with 200, and this c here is the intercept, so we can replace that with 700. So the final answer to the equation of this line is m equals 200n plus 700. In this question, we're told that there are n students in a class, and 2 of the students are going to be selected to play a game, and we need to find an expression in terms of n for the number of ways that those 2 students could be selected. To do this, we're going to imagine picking the first student. If there are n students in the class, there are n different ways of selecting that student. Then we're going to imagine picking the second student. Well, we can pick any other student in the class apart from the person we've already picked, otherwise we wouldn't be picking 2 different people. That means there are n minus 1 students left to pick from, so we could multiply this by n minus 1, which we could write as n bracket n minus 1. So this will be the number of ways of selecting the first student multiplied by the number of ways of selecting the second student. However, there is one problem you do need to consider. Let's imagine we had 2 students that we selected called Anne and Ben. If we selected Anne as the first student and Ben as the second student, this would actually be the same selection as if we selected Ben as the first student and Anne as the second student. It wouldn't actually matter, we'd have just selected Anne and Ben. This means we've actually counted each of the possible selections twice. So we need to half our answer. So it's n bracket n minus 1 divided by 2. In this question, we need to show that triangle ABC is a right-angled triangle. You'll notice we have all of the angles here in terms of algebra. You should know that the angles in a triangle add up to 180 degrees. So let's add up all of these angles and set it equal to 180. So the first angle, 3x minus 11, add the second angle, 5x minus 20, and add the final angle, x plus 13. This must all add up to give 180. Now we've just got an equation to solve to find x. If we add up 3x, 5x, and 1x, we get 9x. And then if we do negative 11, subtract 20, add 13, we get negative 18. And this of course equals 180. We can now add 18 to both sides. If we add 18 on the left, the negative 18 will cancel, so we've just got 9x. And if we add 18 on the right, 180 plus 18 is 198. Then we can divide both sides by 9. 9x divided by 9 is 1x, and 198 divided by 9 is 22. So we find that x is equal to 22. But how does this help us show that this is a right-angled triangle? Well, now that we know the value of x, we could substitute that back in to find the size of the angles. This one here looks like it might be the one that's a right angle. So if we do 5 lots of x, which is 5 lots of 22, and then subtract 20. If you do this, you end up with 90. So we've shown that angle ABC is equal to 90 degrees, in which case the triangle is a right-angled triangle. In this question, we have Annabelle who's going to run 2 laps of an athletics track. She's going to run the first lap at a constant speed, but the second lap speed is going to be 25% greater than the speed of the first lap. And we need to decide what effect this 25% increase will have on the time it takes to complete the second lap compared to the first. In this question, we're going to use the formula speed equals distance divided by time. There are a few different ways of approaching this question. One way is just to assign some numbers. So let's imagine that the first lap is a distance of 400 meters. And let's say that Annabelle runs this in 50 seconds. We can work out her average speed here by doing distance divided by time. 400 meters divided by 50 seconds gives you 8 meters per second. Then we think about the second lap. Well, the distance can't have changed because it's the same track, so it's still 400 meters. But we know the speed is going to increase by 25%. If you do 25% of 8 meters per second, you get 2 meters per second. And if we add this on, we end up at 10 meters per second. We can now work out the time taken by doing time equals distance divided by speed. So 400 divided by 10, which is 40 seconds. Now let's ignore the fact that Annabelle's just broken the world record for the 400 meters and compare these two times here. So the first lap was done in 50 seconds, but the second lap in 40. This means the time has been reduced by 10 seconds. But what percentage has it reduced by? To do this, we would write down how much it changed by, which was 10 seconds, over the original time, which was 50 seconds, and times by 100. If you do this, you end up with 20%. So we can see the time is reduced by 20%, which was less than 25%. So we tick the first box. In this question, we have a graph of equation y equals 2x plus 3. And it's going to be translated by this vector here, 0, negative 4. The vector 0, negative 4 means to move 4 units down. When you transform a graph in the vertical direction, you just add or subtract the number that corresponds to the number of units you've moved. So if we take the original graph, y equals 2x plus 3, and we're going to move it 4 units down, we just subtract 4 from this. All we need to do now is just simplify. 3 take away 4 is negative 1, so it's y equals 2x, subtract 1. In this question, we have a regular pentagon, a triangle, and a regular polygon. We're told that these two lines here are straight lines, and we need to show that the regular polygon is a decagon. We're going to start by looking at this regular pentagon here. We can calculate the size of each of the interior angles using this formula, where n is the number of sides. A pentagon has 5 sides, so let's change those n's for 5s. So if you type in 5 take away 2 times 180, divide by 5 into your calculator, you get 108. So the interior angle of a regular pentagon is 108. I'm going to mark on 2 of these angles here. Next, we're going to look for these 2 angles. Well, since we know that ABCD and EFC are straight lines, we can just subtract 108 from 180 to get these. So 180 subtract 108 is 72 degrees. So both of the purple angles are 72. Next, we're going to find this angle here marked in green. We'll do this by subtracting the two 72s from 180, since the angles in a triangle add up to 180. So if we do 72 plus 72, which is 144, and take this from 180, we get 36. So the green angle is 36 degrees. Now, since ABCD is a straight line, the green angle is actually the exterior angle for this regular polygon that we're trying to find out how many sides it has. To find the number of sides of a regular polygon, we can use the formula number of sides n equals 360 divided by the exterior angle. But we just said the exterior angle for that regular polygon was 36 degrees. So we do 360 over 36, which is 10. So we know the shape has 10 sides, which is a decagon. In this question, we're told that town A is due south of town B. Let's draw a sketch of what this might look like. So we've got town A, which is south of town B. We're then told the bearing of town B from town C is 100. So town C must be somewhere on the left over here, so that when we draw a north line and then connect it up to B, this angle here will be 100 degrees. Then we're told that town A and town C are both the same distance from town B. Now at the moment, our diagram doesn't look like that. Town A looks like it's much closer to town B than town C is. So let's move town A down a little bit so that it's about the same distance and draw in this line here. So line AB is now the same length as line CB. We've been asked to work out the bearing of town C from town A. So let's connect up town C and town A. And if we're doing the bearing from town A, we want to imagine we're at town A, facing north, and we turn clockwise until we face town C. So it's this angle here. Since town A is south of town B, we can be sure that the line from A to B is also going north. This means it's parallel to the north line drawn out of C, which means we can use alternate angles to show that this angle is also 100 degrees. We can now find the 2 missing angles inside this triangle. We do this by doing 180 subtract the red angle 100, which gives you 80, And then since these two angles are the same because it's an isosceles triangle, we can divide this by 2, which gives you 40. So both of the green angles are 40 degrees. We can now find the purple angle, the one we want, by subtracting 40 from 360, since these are angles around a point. So 360 take away 40 is 320, which is the answer to the question. In this question, we have similar solids x and y. Since they're similar, we can consider their length, area, and volume scale factors. We can work out the length scale factor because we've been given the heights of both of them. All we need to do is work out what we multiply 6 by to get to 7.2. You can do this by doing 7.2 divided by 6 on your calculator, which is 1.2. This means the length scale factor is 1.2. We can then get the area scale factor by squaring the length scale factor, so it's just 1.2 squared. We can get the volume scale factor by cubing the length scale factor, so it's 1.2 cubed. We can then use these scale factors to work out the missing numbers in the table. So to work out the surface area for y, we would do 240 multiplied by the area scale factor, which is 1.2 squared. If you do this on your calculator, you get 345.6. To find the missing volume for x though, we're going in the other direction. So this time we're going to divide by the volume scale factor, so divide by 1.2 cubed. If you do this, again use your calculator, you'll get 250. In this question, we're going to solve an equation with algebraic fractions. We're going to combine the two fractions together by finding a common denominator first. The lowest common multiple of 4 and 6 is 12, so we're going to rewrite both of these fractions as something over 12. To get from 4 to 12, you multiply by 3, so we need to multiply x plus 1 by 3. To get from 6 to 12, you multiply by 2, so we'll multiply x minus 2 by 2. And this equals 3. We can now combine these to one big fraction all over 12. On the top, we have 3 lots of x plus 1, then subtract 2 lots of x minus 2, and this equals 3. We can now expand out the brackets on the top of this fraction. So we've got 3 times x, which is 3x, 3 times 1, which is plus 3, negative 2 times x, which is negative 2x, and negative 2 times negative 2, which is actually positive 4. We can simplify like terms here. We've got 3x take 2x, which is just 1x, and then 3 plus 4, which is 7. So the numerator is x plus 7, and this is over 12, and that equals 3. To solve this equation now, we're going to multiply both sides by 12. If you multiply by 12 on the left, that will cancel the 12, so you've just got x plus 7, and if you multiply by 12 on the right, you've got 3 12s, which are 36. To finish this equation, we just subtract 7 from both sides. On the left, this will give you x, and on the right, 36 take 7 is 29. So the solution to this equation is x equals 29. In this question, we've been asked to work out an estimate for the median temperature. We're told that this histogram represents 90 days. So if we do half of 90, we get 45. So we're looking for where the 45th day is. To do this, we're going to need to work out the frequencies represented in each of these bars. We can do this by working out the area of the bar. So for the first bar, we multiply its height, or its frequency density, which is 2, by its class width, which here you can see going from 0 to 5 is 5. So 2 times 5 is 10, so there are 10 days represented in this bar here. Let's do the same process for all of the bars. This one has a height of 1.6 and a width of 7.5, and if you multiply those, you get 12. The next one has a height of 7.2 and a width of just 2.5, and if you multiply those, you get 18. And the final bar has a height of 5 and a width of 10, and 5 times 10 is 50. So we now know how many of these days are represented in each of the bars. Remember, we're looking for the 45th day. If we add up the first 3 bars here, 10, 12, and 18, you get a total of 40, so we're nearly there. It means we just need 5 more from this bar here. If this bar has 50 days in it, and we only want 5 of them, that's 10% of the bar. The bar has a width of 10, so we want 10% of 10, which is just 1. So we just want to go 1 across, which is this far here. So that purple section that I've shaded there represents 5 more days. Since we've only gone across 1, this value here is 16 degrees, which is the answer to the question. In this question, we need to work out the area of triangle ABC. In order to do this, we're going to need to know the size of one of the angles. Now, it doesn't matter which angle you choose to find here, I'm going to find this angle here at the top, which I've labelled A. If that angle is labelled as capital A, the side opposite must be lowercase a. The other two sides must then be lowercase b and lowercase c. It doesn't matter which way round you label those. We're then going to find this angle using the cosine rule for angles, which is cos of a equals b squared plus c squared minus a squared over 2bc. So let's write this down but substitute in the values from the question. So cos of a equals b squared, which is 12 squared, plus c squared, which is 6 squared, subtract a squared, which is 13 squared, all divided by 2 lots of b, which is 12, times c, which is 6. If you type that whole right side into your calculator, you'll find that cos of a is equal to this number here. To find the value of a, we can then just use inverse cos. So a is equal to inverse cos of this number, which gives you this number here. So a is 85.61 and so on degrees. So let's add this a to our diagram. Now we're ready to find the area of the triangle using this formula. The area is equal to half AB sine C. I'm now going to relabel the triangle. Originally I had that angle as capital A, but for this formula I want it to be capital C, in which case the side opposite it is lowercase c, and the other two sides are now A and B. Using this formula then, the area is equal to 1/2, multiplied by A, which is 12, multiplied by B, which is 6, multiplied by the sine of C, which is the sine of that angle that I got previously. So if you type all of this into your calculator, taking care to make sure you use the full number for the 85.6, don't just round it off, you'll end up with this number here. Now we can round off our answer though, 35.9, or perhaps 35.89 would also be acceptable. In this question, we need to work out an equation for y in terms of x. We can see we've got this ratio above. When things are written in a ratio like this, you can just divide the parts on each side and form an equation. So on the left-hand side, we've got y to 8 in a ratio, so if we do y divided by 8, this will be equal to the right side divided, so 9 divided by x squared. Now to form an equation for y in terms of x, we can just multiply both sides by 8. If you multiply by 8 on the left-hand side, the 8 will cancel, so you just have y. And if you multiply by 8 on the right-hand side, you'll need to do 9 times 8, which is 72, so it's 72 over x squared. And that's the answer to the question. In the second part of the question, we need to work out the value of y when x is equal to 3/4. We're going to use the formula that we created from the previous part. All we need to do is substitute x for 3/4. 3/4 is equal to 0.75, so we can do 72 divided by 0.75 squared. Do this on your calculator and you get the answer 128. In this question we have a spinner, and we're told that Maisie is going to play the game 3 times. We need to work out the probability that she wins at least 2 large prizes. The first thing we need to do is work out the size of the angle for the large prize. We can do this by subtracting the other angles from 360. So 360 take away 200 and 128 gives you 32. So the angle for the large prize is 32 degrees. This will allow us to give you the probability of winning a large prize on any given spin. So the probability of a large prize is the angle, which is 32, out of the total angle, which is 360. If you type this into your calculator, you'll see it will actually simplify to give you 4 over 45. That's going to be slightly easier to work with. Now, it would also be helpful in this question if we knew the probability of not winning a large prize, which we could write like this. We could find this out by subtracting the probability of winning a large prize from 1. So if you do 1, take away 4 over 45, you get 41 over 45. So we now know the probability of winning a large prize or not winning a large prize on any given spin. But Maisie's going to play the game 3 times, and we need to work out the probability she wins at least 2 large prizes. So we're going to consider all of the ways where she could win at least 2 large prizes. The first of those is if she wins a large prize on the first 2 spins, but doesn't win one on the last spin. So large, large, not large. She could also win one on the first and last spin, but not on the middle spin. So large, not large, large. Or she could not win on the first, but win on the next 2. So not large, large, large. So these are all of the examples of winning exactly 2. But the question does say at least 2. So we could also win all 3 of them. That would still be at least 2. So large, large, large. We just need to work out all of these probabilities, then add them together. Let's start with the first one, the probability of a large, then not a large prize. So large on the first go is 4 over 45, multiplied by large on the second go, also 4 over 45, multiplied by not large on the third go, 41 over 45. In the second example, we've got large, not large, large, which would be 4 over 45, 41 over 45, and 4 over 45. In the third one, it's not large, 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 which is 41 over 45, then 4 over 45 twice. And in the final one, it's large all the time, so it's 4 over 45 times by itself and itself again. If you type each of these into your calculator, you'll get the following answers. 656 over 91,125, and you'll actually get that for the next two as well. And the bottom one will be 64 over 91,125. So all we need to do is take these probabilities and add them together. And if you do that, you'll get 2,032 over 91,125. You're also welcome to give this as a decimal or a percentage. I just think a fraction is the easiest one to do. To start this question, we're going to work out what fg of x is. To do this, we're going to take the f function, but then replace its input with the entire g function. So if we write out the f function, but replace the x with a bracket, so instead of x squared minus 6, it's going to be bracket squared minus 6. So fg of x will be bracket squared minus 6, but inside that bracket we need to put the g function, which is 5 minus x. When we square a bracket, that's multiplying it by itself, so this is 5 minus x times by itself, and then subtract 6. If you expanded this, you do 5 times 5, which is 25, 5 times negative x, negative 5x, negative x times 5, which is also negative 5x, and negative x times negative x is positive x squared. And then we have subtract 6. We can simplify this, so if we start with the x squared, then if you simplify the 2 minus 5x's, you get minus 10x, and then 25 subtract 6 is 19. So this is fg of x. We also need to do gf of x though, and this is the same idea but the opposite way around. We start by writing the g function, but replace the x with a bracket, and then insert the f function into that bracket. So the g function is 5 minus x, so that's 5 minus a bracket. And inside that bracket goes the whole f function, which is x squared minus 6. This is equal to 5. Now you can imagine this whole bracket is times by negative 1, so negative 1 times x squared is negative x squared, but negative 1 times negative 6 is positive 6. To simplify this, we add the 5 and 6, which is 11, so it's 11 minus x squared. So we've now found the functions for fg of x and gf of x. If we look at this inequality here, we've got fg of x is less than gf of x. That's what we're trying to solve. So we can write down fg of x, which is x squared minus 10x plus 19, is less than gf of x, which is 11 minus x squared. Now we need to solve this inequality. We're going to get all of the terms on the left-hand side so that the right-hand side is 0. To do this, we would need to add x squared. On the left-hand side, there's already an x squared, and if we add an x squared, we get 2x squared. We've got minus 10x on the left-hand side, which will be unchanged. But to get rid of that 11 on the right-hand side, I need to subtract 11. So I'll subtract 11 from 19, which gives you 8. Now all terms of this quadratic are even, so we can divide both sides by 2. On the left-hand side, if you divide by 2, 2x squared divided by 2 is 1x squared, negative 10x divided by 2 is negative 5x, and 8 divided by 2 is 4. On the right-hand side, you can still divide by 2, 0 divided by 2 is 0. So we end up with this quadratic here. This one will factorize, it's x minus 4, x minus 1 is less than 0. And to solve this, we're going to consider its critical values. To do this, we imagine it says equals 0 rather than less than 0. If it did equal 0, we'd get two solutions, x equals positive 4 and x equals positive 1. These are our critical values that we're going to use on our graph. If we draw out a graph of this, it would be a U-shaped quadratic, which would now cross at these critical values of 1 and 4. We're interested in when this graph is less than 0, which is this section here, because it's below the x-axis. We just need to consider which x values give us this section of the graph. Well, the x values that give us this section of the graph are to the right of the 1 and to the left of the 4, so in between 1 and 4. So that's how we form our solution. X is in between 1 and 4. In this question, we're told that liquid is going to fill a cylinder at a constant rate, and we need to show that it takes more than 1/4 of an hour to fill the container. If we're going to work out how long it takes to fill the container, we'd do the volume of the cylinder and divide it by the rate at which liquid is flowing into the container. You might notice that in this question, all of the values have been given to a degree of accuracy, the nearest centimetre or the nearest 100 millilitres. This means that when we work out the time, there'll actually be a range of possible values, depending on the value we take for the radius, height, or rate of flow. The question is asking us to show that it takes more than 1/4 of an hour to fill the container. So all of this range of possible values needs to be greater than 1/4 of an hour. So the value we're particularly interested in is the lowest possible time that it could take. To find the lowest possible time it takes, we want this cylinder to be filled as fast as possible. The cylinder will fill fastest if its volume is lowest. So we're interested in finding the minimum volume. The container will also fill fastest if liquid is flowing in at the highest rate. So we're looking at the maximum rate of flow. So let's start with the minimum volume. To find the volume of the cylinder, we're going to need to use these values here. So the radius is given as 10 centimeters to the nearest centimeter. This means it must be in between 9.5 and 10.5. The height is 25, also to the nearest centimeter, so it must be in between 24.5 and 25.5. To find the volume of a cylinder, we use this formula here, pi r squared h. Now remember, we're looking for the minimum volume of the cylinder, because we want it to be as small as possible, so that it fills as fast as possible, and we find the lowest amount of time. To do this, we'll use the smallest value for the radius and the smallest value for the height. So the volume will be equal to pi, multiplied by the lowest radius here, which is 9.5 squared, multiplied by the lowest height, which is 24.5. If you type this into the calculator, you end up with this value here. So this is the smallest volume the cylinder could possibly be. Then we also said we wanted the maximum flow. Well, we're told the liquid flows at a constant rate of 0.4 litres per minute, but to the nearest 100 millilitres. 0.4 litres is the same as 400 millilitres. So the flow must be in between 350 and 450 millilitres. We said we're going to use the maximum flow, so we want to use the 450. So we can now work out the time it takes by doing the volume of the cylinder divided by the rate of flow of liquid, but we're going to use the lowest volume and the greatest flow. So the lowest volume was 6946.45 and so on, and the greatest flow was 450. If you do this on your calculator, you end up with this number here. 1/4 of an hour is 15 minutes. So we've shown that this is greater than 15 minutes, or greater than 1/4 of an hour, as the question required. In this question, we need to find an expression in terms of k for the surface area of the pyramid. We're told that each of the faces of this pyramid is an equilateral triangle, so let's draw out one of those triangles. Since it's equilateral, all of the side lengths must be the same, and we've been given one of those lengths in the question is k, so they're all k. In an equilateral triangle, the interior angles are also the same, they're all 60 degrees. To find the area of one of these triangles, we're going to use the formula half AB sine c. So we're going to label the triangle, we'll pick one of the angles to be C, I'm going for this one in the bottom left, which will mean the side opposite is lowercase c, and the other two sides must be A and B. Now we can just substitute these into the formula, so the area will be equal to 1/2, multiplied by A, which is k, multiplied by B, which is also k, multiplied by the sine of C, which is sine of 60. If you do sine of 60 on your calculator, it will give you square root 3 over 2. We can simplify this by multiplying the half and the square root 3 over 2, which gives you square root 3 over 4, and then the k times k is k squared. So this is the area of one of the triangles. But this pyramid is made up from 4 of those triangles, so we need to multiply this by 4 to get the total area. So the total surface area will be square root 3 over 4 k squared multiplied by 4. If you multiply this by 4, these 4's will cancel, so you get the answer, square root 3 k squared, and the answer to the question. Thank you for watching this video, I hope you found it useful. Here are some suggested grade boundaries that you might want to use, but remember we won't know the real grade boundaries until after the papers are actually done. Subscribe to my channel so you don't miss out on future videos, and if you did find this useful, I'd really appreciate if you like, comment or share this video.